All right, Assalamualaikum and very good morning, everyone. As I mentioned before, today we're gonna have a new topic, which is introduction to programming structure. So right now we're already on week 7, and we already learned a lot of things regarding the problem solving, starting from chapter 1, how we can identify regarding the general problem solving. Chapter 2 is on how you can identify the problem based from the case study. Chapter 3 regarding how you can design the decision for 6 and so on, regarding the decision and so on. Okay, so there is important parts in problem solving, and it's not only for the problem solving itself, but in terms of the programming. So in terms of the programming, there is a one important part that we call as a modular. So this topic we're gonna see what is the modular and how we can discard or how we can separate the big case study, the problem into a certain solutions, right? Okay, so there are four terms in this topic that I need to cover. And basically, I want to cover regarding the module and function first because that one is more general in the problem solving. What is module and so what is functions? And basically, these two terms have a similar meaning actually. And later on, we're gonna see on what is cohesion and also coupling here. So there is different things regarding cohesion and coupling. Even though you see that they may have a similar features or similar uh, meanings in terms of cohesion and coupling, but in terms of the implementations, they looks different. All right, okay. So what is the outcome of this course actually? So you should be able to differentiate between cohesion and coupling. Later we're gonna see what is cohesion and what is coupling, how we can design the cohesion and coupling in the modules, and explain the difference between local and global variable. And every time we do the modules or the function, we're going to look on the local variable and global variable. What is local variable? Where we need to declare the local variable and where we need to use this local and global variable in our solution, especially on the algorithm, and explain how to use the parameters. So this parameter we need to set in the modules. Either the module receive any parameters. What we call parameter is some kind of the you are passing a data to this that module. Okay, that will be used in that module. Let's say for example you have one program, and this program you can data in different modules. This module is specific to capture the data from the user, and then you want to pass the data that you enter to the calculation modules. So right now we have two different modules that we have here. Let's say for example, this one is a read module. Second one here is calculate module. So read module here may be purposely to key in or read two numbers, for example, and this calculate module specific to calculate total of two numbers. So right now we have two modules. The first module here is read module, and the second module here is the calculate module. What is the meaning of the parameter here? You will pass these two numbers. Let's say for example num1 and also num2 to this calculate module. For what the purpose here is that, so the calculate module doesn't read the modules. So the calculate module here is specific to calculate only without any entering a data of two numbers. But the read module is specific to read a modules, read a numbers of two numbers. So right now number one and number two here we call as a parameters. Okay, so parameters. Further explanation I will give you later in the next slide. Okay, so student able to draw coupling diagram correctly based on the given algorithm. Okay, later we're gonna see how we can design the coupling and also cohesion. Okay, cohesion and also coupling. To be basic regarding this cohesion coupling, cohesion is within the module, okay, within the module. But for the coupling is inter-module, means it has connection between read and also the calculate module. I can say that coupling here is reflect to this example that I gave just now, because we have a parameter of two numbers here, and these two numbers we pass or we interact with the calculate module. So we have two couples, one couples here, okay. So we have one module and the second module, one couple. That's why we call this one as a coupling. The student can be write down all the variable in the given problem. Of course, whenever we talk about the problem solving, we cannot what you call we need to identify the suitable variables. Is it constant value? Is it we need to key in the data based on the case study. Right. So the expected outcome of this is to explain the need of structured programming. Okay, for the first time, you learn regarding the structured programming. Structured programming means that we are doing starting from 1, 2, 3, 4, 5, 6, and so on. It's structured. It's linearly structured like way. Later in the next subject you will took in the next following semester is about OOP. Regarding this one, it's called as a object oriented programming. It's totally different compared to the structured programming. We have a structured programming, we have an object oriented programming, we have a dynamic programming, just to be some knowledge regarding the programming that you will see in the next following semester. So I explain the design of modules and functions in terms of cohesion and coupling. Okay, so all these kind of the notes is come from these books that I already given in the earlier of the semester. It's from the Spanker and Hubbard 2012. And this book is very good for the problem solving and programming concept before you want to do the programming technical itself. Okay, so just to
So
give you some idea. So what is module and function actually? So let's say you are a designer or an engineer in the car manufacturer, that you want to design a car, something like this one. Okay, so you need to specific the purpose of each component. All right, so we have a components of the tires here, we have a lamp, okay, we have a screen here, we have a windshield, okay, we have a mirror, left side and also right side mirror, front wheel, back wheel. What else? We have a bonnet, right? Okay, we have a signal, whatsoever, and so on. All they can call as a module, and each module have a specific functions. Okay, for example, we have a front tire and also back tire here. They have a different specific function. Okay, so inside the bonnet here we have an engine. Okay, that will what we call uh move your all parts in the car components. Okay, so without the engine it cannot be run, regarding your tire cannot be run, you can start your car and so on. So imagine that the engine is connected to other parts in the car. Okay, so this is what we call as an interconnection between the component and the other components. Try to reflect again with the cohesion and also the coupling. Okay, more details here regarding how we can design a car. Okay, so we have different parts. We have a door here. Okay, the function of the door here is to make sure that the passenger have a, a safety. Okay, we don't have any open door that when we are driving, we don't have any open door like this one. And then if there is some raining and so on, something like that, okay, your car inside is not wet. We have what you call another things here. We have a trunk, tail light, back fender, quarter window, roof board, and so on and so on. Then each of these components have a specific type, has specific function. All right, okay. And what about this one? I think all of you know regarding this one. We have a new model of iPhone 12, right? Okay. So each of the every kind of the variation of iPhone model, they have different kind of module, for example, something like that. Okay. So can we try to identify what kind of component that we have in this phone? Okay. For
Sir,
example, yes.
ada orang nak masuk Google. Ni.
Okay. Anyone? Okay. Right. Can I continue? All right. For example, we have an iPhone here. A very latest model of iPhone is iPhone 12. Okay. Right. And we have some common of battery, whereas we have some kind of the haptic function here. And then we have a camera, rear, front camera, something like that, and so on. What about what else? We have a speaker. What is speaker here? I don't know what is speaker. Let's say here there is speaker, here is speaker, and so on. And each of these components is connected into one board. Okay, one board, we call it a circuits here. So the camera is connected to the circuits, battery is connected to the circuits. What else? A speaker is connected to the circuit, and so on. All right, okay. So this just to give you some idea. We have some product is iPhone. Imagine that we have some case study problem. We want to cascade or separate uh, the case study into separate problem. All right. So the problem we want to have it here, okay, this one is a battery. We want to make sure that the battery is sufficient enough to run one new iPhone model, something like that. Okay, we want to improve regarding the speaker here. So we just improve the speaker. Okay, and then we want to improve the camera. We only just touch little bit on this camera function and improve the camera density or the resolution, something like that. Okay, okay, in terms of the programming and problem solving, just now we look on the real world of how we can separate our product into components. Okay, so how we can separate our case study into different problems or different modules. Right, try to look on this example. We have one example here we call as an interest control. Okay, this is the name of the solutions. Okay, we have a read functions, and then we have a calculate function, and then we have a print functions. Remember that we already touched a little bit on this one: read, calculate, and print functions. All right. Okay. So read, they had a specific function in order to capture the data from the user, key in. Calculate, we do specific for the calculations only. Print, regarding this one, is when to display the product of calculations, and each of these module have a specific task, or we have a specific function here. Okay, example, read an input. Okay, we enter principal, interest, and years, and also times here. So we have 1, 2, 3, 4 data that we need to key in by using a keyboard, for example. Okay, so we have the interest equal to interest divided by 100, because we need to have here in percent. And then we exit the function of reading, and we do the calculation for it. Once we enter the data, So this data will be do the calculation. Is basically data come from the read function. Then we have here the calculations, and then we have exit. Exit here means that we done for the particular functions. Okay, we done for the, for example, this exit is done for the read function. Exit here is done for the calculate function, and the last one here we just to print out the product of the calculations from the interest control. All right, okay. So can you see here, starting from the interest control, down here, read a function, and then down here, calculate function. Down here again, we do the print function. This is what we call as a structure. Okay, we call as a structure. It's linearly one until and so on. It's totally different if you learn regarding OOP because this one is based on the object. Right. So I don't want to touch regarding this object because you will learn with the OP in the next following semester. Right. So writing a program, we consider the structure of the program. Okay. So there is a basic process that you need to look regarding this one. Okay. Try to remember in terms of the how we can capture the problem steps. We have 6 steps here, and we have first one we need to identify the problem. And then we need to break the problem into module or the sub module. This is what we call the, we need to separate the problem here into different of a module. Let's say this is a big module, sorry, this is a big problem that we have. Okay, and then we need to cascade into different kind of a module that have a specific functions, right? Write algorithm for each module, and then we do the algorithm for it, and this one is reflect the algorithm because each of the module have its own algorithm. Test the algorithm for each module, and then of course each module, and we're gonna have some kind of test taking in order to test the efficiency of the each module. Last one, we write the next module. Let's say this already done this one, we check a module is okay, and then we do the next following module. Okay, right. So this is another example regarding in terms of the, if you still remember, this one is called as IC, interactivity chart, how the modules interact each other. Okay, so this one is a reading, calculate, and print. Previously, you learned regarding these 3 module, and it has own specific, but doesn't have any connectivity between read, calculate, and print. Okay, so right now we have some kind of the informations regarding the cohesion and also the coupling, how we can make these functions have relations. Okay, how read can pass data to the calculate, okay, and then calculate into the print. Sorry. So rule for designing here for the models here. I don't want to look more detail regarding this one. You can read basically on this one. Just to be clear regarding, we need to have rules in order to design a module. Okay, in terms of the entity itself and entrance and one's exit. Okay, this one reflect to the parameters. A single function printing, calculating, whatsoever, and so on. And this is what we call as a one function have a specific task. A short, readable, and modified. Okay, so what the meaning regarding short here? So each of the module cannot be too long. Okay, to be just to be give some understanding regarding the short here, it's not necessary to have a short. It depends how you can design the, how you can solve the problem, okay, by using the modular length of the module. And that's why I said it depends on the length of the module, depends on the function and instruction number. If you have one function that have very complex of it, okay, you may have one module that is a very long module, right? So developed to control the order of processing. Okay, so develops to control the order of processing. Let's say you want to control the example like this one, it's interest control. Okay, We want to control regarding the such a programming here. You cannot do the print without the reading first. So you need to read, do the calculation, and then you print out. You cannot calculate without any reading numbers. Okay, so there are different types of modules. You have a control modules, okay, in order to display a flow of the data. Initialization module, process instruction that execute by only the beginning. Process module, we have a tree. A process module here, we can, if you reflect regarding IPO, okay, so this falls under the processing parts, this one. Okay, calculation module, okay, print module, read and data validation module. Let's say, for example, we have a decision if else. Okay, you want to do some kind of a while looping. It falls under here as well. Okay, wrap up module process instruction that execute only at the end. And then the last one here is regarding the event module. I don't want to touch more detail regarding this one. Okay, basically in terms of the knowledge, just to remember in terms of the theory, the type of the module. Okay, so we move on the important part here regarding the cohesions and also couplings. Okay, so what are about cohesions here? Like I mentioned before, cohesion is within a single function or the single module. Let's say I have here read module. Okay, cohesion is only inside here without any interaction between the other modules, but different in terms of the coupling here. Of course, it's couple, it's supposedly have two, a partner, okay, one and also two. If you have only one module, we don't call it as a coupling, we call it as a cohesion. So these two modules, okay, these two modules, as I read and calculate here, have connectivity. For example, whenever you enter data from the read module, so this module maybe can pass a data to the calculate module you to do the calculation parts. Okay, so you are passing a certain specific task to the other module to do their job. Calculate module, right? Okay, so what is cohesion chain? Like I mentioned just now, okay, it works independently within the module as possible from the rest of the other module. So works independently. So each module should have a single entry and a single exit. Right. Okay. As nice as it is, it's not realistic. Module needs to share data at the module in order to complete the modular task. So there is another term that we call as a modular. So modular here we call it a each of the module must have the connection between modules. Okay. So otherwise it's not being realistic. Okay. Try to reflect with our example previously in iPhone. Okay, you cannot run an iPhone without any a battery is embedded. The battery must be connected into the board. The camera must be connected to the circuit, so on and so on. It must be connected each other. So connectivity we call as a modular in order to complete a one iPhone, something like that. Okay, so this sharing of data is called as a coupling. Will be next being explained by me later. Just to give you basic understanding, basic differences between cohesion and coupling. So this is it. Okay, we move on. The next part here is coupling. Remember again, coupling must have two modules connection each other. Okay, it's accomplished by one type of interface between modules that enable data to pass from one module to another module. The minimal instruction module independence. Okay, couple allows for the communication between modules. Communication between modules. You want to pass data from here to here, we call it a coupling. A measure of the strength of independence of the one module to another module. So right now we focus on the complexity between modules and other module. Okay, so we don't bother regarding how you can design the coupling here. So we just know what is the complexity, or we call it how complex is a module that you want to pass certain data to the other module. Certain cases you don't have any coupling, okay, you only have a cohesions. So you will see regarding this one more detail, and you will understand if you do the programming. Okay, you want to do programming. Later I will give you some example how the process of the coupling being done. It's very simple program. Okay, so this is another things here that you can read by yourself regarding the degree, the easiness, and also the flexibility of the coupling here. Okay, so we have a cohesion and also a coupling. Comparison between these two terms for the modules. Cohesion is within the modules. Okay, coupling is between modules. Between modules. Okay, between modules. Within the module here, let's say, is still under the within module. Focus on one single task. Let's say it's reading module, is read module is only with this one reading module. But it's coupling dependency between module. Let's say read and calculate. Is do something here. Read passing a data to the calculate. So connection intra-module concept within the module. Interconnection. Okay, so this in terms of the graphical, how we can design our program, how we can design our solution by using cohesion and coupling. So it's by using this solid line and dotted line. So solid line here we call as the cohesion is within the module. Okay, within the module. So coupling here is interaction between module 1, is for example module 1 to the module 2. Okay, so this is the interaction between the B into the C here, right? So if module 1 perform task 1 successfully, it may be required to provide data to module 2. Okay, for example here, so cohesion result from having separate modules, coupling result when data are passed from module 1 to module 2. So right now we have we have a interaction between module 3 and also module 4. Okay, so just to give you some idea how the cohesion and coupling looks like. Right. Okay, so we move on this one. Before we move, I move on the cohesion and coupling reflect to this global parameter and return value. I want to give you some example in terms of the coding. Okay, so this is one example, a very simple example of modular. So this program is to calculate two numbers. Okay, I fix the value of A and also B here, reflect to number 1 and also number 2. And then I have another variable that will store the product of additions. Okay, so and I have a function here. So this is what you call as a function or the module. All this one is called as a module as well. But inside here, I have another module we call as a calculate functions. So this calculate function here is one of the module that I have to design to specific to calculate two numbers. Okay. So what is that module? The module is here, line number 12 until 16. So what is happening here? Okay, I want to pass two value, A and also B, which is A, the value is 1, B here is value is 2. So right now I want to pass value 1 to X, value 2 to the Y. Okay, so this is what we call as a coupling. So the main function here, the main module here, I want to couple it into the calculate function by using this calling function. And the passing parameter that I call is this one. A and B here we call as the actual parameters that you want to pass into this function. And then you can design into the different kind of variable. So X will receive the value of 1, while will receive value of 2 from this one, even though we don't have a, even though the variable name is different. Okay, So A and B here we call as a local variable because this A and B only applicable in the main functions. Same with the X and Y here we call as a local variable which is applicable only in the calculate functions. Okay, so you can put here as a here, okay, because A here is only usable in the function of main A here, right? So to avoid this one, you can have another variable that holds the value from this one to here. Okay, so now I'll go back to the slide just now. This is what we call as a global variables, parameters, and later we're gonna see about regarding the return values. What is meaning return value is that whenever we go for that particular modules, do some calculation whatsoever and so on, we want to pass again to the other modules. The interactivity is continuously happen. Okay, so right now is we call it as a local, global, and also parameter. What is the differences between local and global variable? What is parameter? So local here means that uh, let's say for example we have a module, okay, integer x and also integer y. Let's say this one is a read module. So x and y here we call it a local variable. Okay. So global here is you need to have, let's say you have a very big program. Inside here you have a read module, you have here a calculate module, and the declaration of this variable is outside of the modules that we have here. Let's say integer x and also integer y. So global here is module read and also module calculate can utilize the variable directly. It gets called from this read module, from calculate module. Yes, of course, because the global here means that any modules can access of this variable. Okay, there is certain things that we need to consider. Why we need to set as a global? Why we need to set as a local? Reflects together regarding the security of the data. Okay, if you want to keep okay, let's say for example I want to keep this data is only applicable in this module. Okay, and that data is safe in this module instead of I want to set as a global. It can be accessed by the other modules. So in terms of the what you call it the security parts, so it can be done by the local. But normally for the global here, for certain cases only. Okay. So what is local variable here? The local variable is defined within a module and a given local scope. So the usage of this variable is very specific. It cannot be used in other modules. So unknown to other modules and to the other main program and used only by the module itself. Like I mentioned just now, so it's enabled to the cohesion of the modules. Okay. So allow duplication of variable name in different modules. What is meaning here is that let's say I have here read integer x and also integer y. I have another one here is calculate, and then I have another variable that have the same name as the read module here. Let's say integer x and y. Okay, let's say for example integer x and y in read module here is 1, this one is 2, this one is let's say 3, and also is 4. So this cohesion here means that this variable is only applicable, okay, it's only useful in within of the module. Okay, we don't have any interaction between read and calculation. So x here is still 1. It cannot be replaced by 3 because the x equal to 3 is only within the calculate module. This is what we call as a local variable. It's locally being used in each of the modules. So allow sharing the same values, okay, the same values variable in different module by combining module through parameter or return value. I say we have another interaction, pass back to the read module and so on and so on. So it will keep the same value. Now is global variable. So global variable we define outside the individual modules. So we call it a global scope. Global to the program, visible to all module. Okay, visible to all module. Imagine that the data that you have is visible to all modules. It's not safe enough to keep your data properly. Okay, so that's why we have here something like is allow for data coupling. Okay, there is certain cases that can use for the data coupling. Module share data variable that will be used in the other module. Okay, for example, I have here control module, variable X, Y, and Z here. Module 1, I have another variable D, E, and F. Module 2, I have G, H, and I. And module 3, I have X, J, and K. So the control module here, okay, the main module, I call it as the main module. I have variable X, Y, and Z. So X, Y, and Z here can be accessed by the module 1, 2, and also module 3. But variable D is only applicable in module 1, E only 1, F and only 1. Okay. Similar if you have a G, H, and I, is only applicable in this module only. X, A, J, K here is only applicable in module 3. Okay. Now we move on. This one here is variable regarding the parameter. So variable is used in subroutine to refer to one of the piece of data provided as input to the subroutines. So this one we can allow value that can be passed into the functions. Okay. Let's say for example, I have a calculate function just now. Okay, I want to pass A and also B, which is A equal to 1, okay, B equal to 3. And this one, this value is want to pass to this function. So calculate function will receive two parameters, parameter 1 and parameter 2. This is what we call is a parameter. Okay, local variable, they pass or send from one module to another, a kind of a variable. Okay, another way for of facilitating coupling that allow the communication of data module. Okay, so this one is another way we want to do interaction. So from the modules want to pass to this calculate functions, we want to pass these two parameter. Okay, for example, reading data A, B, and also C is called as a parameter. So in the parameter, we have what we call terminologies. The formal parameter and also the actual parameter. The calling modules and the call modules. Okay, call by value and also call by reference. All right. So regarding this formal parameter and actual parameter, calling module and the call module, call by value and call by reference, so reflects to the modules itself. For example, I have here a formal and also the actual parameter. You see that it look like similar as the coding that I showed just now regarding calculate function. We have num1 and num1 is passed to this display functions. So the actual parameter is from the call module. From the calling modules. So display here we call it a calling modules. So line number 7 here we call as a call module. This one we call is a calling module. Okay, right? Okay. Certain name that in the other books that we call as calling functions. This one is we call as a called functions. A similar thing as well, right? So what is formal parameter? So formal parameter is called as the data that being received from the calling modules. Display is passing num1 to this function. Para1 here is we call it a formal parameter that being received from the line number 4, which is a calling functions. The actual parameter here means that the what you call the module name being processed. Okay, we call it the data that want to pass from the calling module. Like we have here line number 4. We call it the actual parameter. We don't talk regarding para1 here is the actual, because this one is we copy the data from num1 to the para1. Num1 pass to the para1. But basically, it's not doing like this one. Okay. So we actually passing the data, is we not passing the variables. Num1 here, let's say, is equal to 3. Okay, we're not passing num1, but we are passing a number that are stored in num1 to para1. Right? So this is happening here. Okay. So more detail regarding this one, I will share with this one in the next lesson. Right? So we stop until now formal versus actual parameter. And the other explanation I will cover in the next following session. Or I will capture recording, I will share with you for your further reference.